Ok, il est 6 heures, on va commencer. Ok, it's 6 p.m. We're gonna start this MP84 event. We're gonna start with a few opening words. First of all, join us on our Slack channel. You have the link right here. We have also a code of conduct on the Montréal-Python website. And if during this presentation you see any issue related to the code of conduct, you can write us at team@montrealpython.org. We're looking for presenters. We're doing meetings monthly. So if you have something you'd like to present, please let us know. And we also are looking for people to join with the organizing team. And if you would like to join us, please write us on Slack. D'abord, petit mot d'ouverture, on a un Slack channel, le lien est écrit sur l'écran. Dans la chaîne Meeting, c'est là qu'on va poser des questions pendant l'événement et partager des liens vers sondage de satisfaction, etc. Donc, vous pouvez tout de suite nous rejoindre sur le channel Slack. Si vous n'y êtes pas, vous pouvez aussi poser vos questions directement dans les commentaires YouTube. On a un code de conduite qui est disponible sur le site de Montréal-Python et si vous avez des problèmes reliés au code de conduite, si vous voyez quelque chose, n'hésitez pas à nous écrire un courriel. On cherche des présentateurs, on fait des meetings tous les mois. Donc, si vous avez quelque chose à présenter, faites-nous savoir, écrivez-nous un courriel et on cherche aussi du monde actuellement pour rejoindre notre équipe qui organise. Donc, écrivez-nous sur Slack, courriel, comme vous préférez. Alors, agenda for today, so we just did the opening words. We're gonna have the first presentation by Martin Clumsky on advanced command lines. Then we're gonna have module du mois, monthly module with Nguyen. Following that, we're gonna have profiling with Christian Hudon, and then at 7 p.m. we're going to have a 5 à 7 virtual on Jitsi. Donc l'agenda ce soir, le mot d'ouverture, on vient de les terminer. Ensuite, on va avoir une présentation sur les lignes de commande avancées avec Martin Schlemski. Ensuite, on va avoir le module du mois avec Nguyen et une deuxième présentation qui va être sur le profilage avec Christian Hudon. Et à 19h, on va faire un 5 à 7 virtuel avec Jitsi. Donc, on va commencer avec la présentation de Martin. Donc, juste quelques mots sur Martin. C'est un administrateur cloud. Il est en transition pour devenir un développeur Python en ce moment et il travaille à Ubisoft depuis 10 ans dans des rôles d'administration système et il utilise Python régulièrement. We're going to start with the presentation from Martin Chomsky. It's going to be held in French and a little bit about him. He's currently a cloud administrator and he's transitioning into Python developer working at Ubisoft for over 10 years. Okay, here you go, Martin.
Thank you, Isabelle. So today I'll be talking to you guys about the CLIF, which is the Command Line Interface Formulation Framework. Isabelle beat me to the punch who am my slides, so I'll go through this really quickly. I've been working at Ubisoft since 2011 as a cloud administrator for the past 4 years. I do lots of Linux and Python. I just wanted to mention that I use Vim because it's like the best editor ever. And I also wanted to point out that Ubisoft is hiring in my team specifically. If you guys are interested, we're a global team that manages private clouds within Ubisoft. And it's used by over 1,000 Ubisoft employees. And we're looking for people with strong Linux skills in virtualization, containers, and networking, and Python skills, obviously. And if you know OpenStack, that's great. That would be really awesome too. So if you guys are like these sort of, if you're interested in that, then please reach out to me, maybe during the 5 à 7 or on LinkedIn or even on the Montreal-Python Slack. So let's start talking about Cliff. So Cliff, why Cliff? Cliff is an OpenStack project. So OpenStack itself is a series of projects, and one of which is Cliff. But it's not only OpenStack. You can use Cliff completely independently of OpenStack to create CLI applications. So it helps you organize your command line code. And then it's not just like the CLI input, so not just your arguments that you're passing into the application, but the output as well. It's highly pluggable. It's customizable as well. You can write hooks, you can write different formatters for the outputs, and it also supports Sphinx for documentation. I'll just show you real quick. Just give you a little taste. So the OpenStack command is written with the Cliff framework. And as you can see, there is a lot of different commands that in OpenStack. Some of which are actually added when you install extra Python packages. So that's what I meant by pluggable. So it's really big, and it's made for that sort of situation. So packaging. Did I? Yeah. So packaging. Let's go take a look at that. So one thing you need to know about Cliff is that you can't really use it for standalone CLI scripts. You need to. This is made for being for packaging, like for a Python package. This is the setup py file. That it's a very small setup py file. There's a ton of stuff missing. I just left it this small because the focus isn't on packaging, it's really on Cliff. So this is a bare bones one that it will work. It's just enough so that it'll work. So your setup py file has some metadata like the name of the package. In this case, it's going to be called IMDb CLI. So I'm showing you a little demo program that's going to show. It's a CLI for searching and querying the IMDb, the Internet Movie Database. And so you specify the version, the description, and other stuff like that, and the requirements. In this case, IMDb Py, which is a library to access IMDb, Cliff, obviously, and PyTest. If I have time, I'll show you maybe some tests you can write to test Cliff applications. The really interesting bit is the entry points over here. So entry points, you declare one of the entry points is called console scripts, and this bit here will actually, when you pip install a package, it's going to create a command called IMDb CLI, and that command, when you run it, is actually going to go into the IMDb CLI directory. There's a package, and then there's the main module, and within the main module, it's going to call the main function, and that's what happens when you call IMDb CLI. More on that later. This is actually standard kind of setup tools kind of stuff. So this isn't Cliff specific. This is setup tools. IMDb CLI here. This is another entry point. This one is used by Cliff. I'll show you in a bit. So here you actually declare the different actions you want your CLI script to do. So movie create. If you do IMDb CLI movie create, it's going to go and it's going to go into the IMDb CLI package, into the movies module, and there is a class there called movie create, and that class is going to handle the movie create action. And it's the same sort of thing with movie list and movie show. Actually, I had a tree, I forgot to show it, just to give you guys an idea of what the directory structure looks like. So in the package itself, on top, so this is the root of the package. Here, the setup py exists over here. Here's IMDb CLI, that's the package. And this is the main module, which is here. and this is the movies module, which is here. Next, the application. So now we're in the main.py file. In that file, this is where you actually, this is where the IMDb CLI command is going to go and run the main function here. So the main function instantiates an IMDb app object and then calls run on the object. And so what is the IMDb app class? So the IMDb app class is a subclass of the app class that comes from Cliff, in which you override the dunder init method, and then you call the superclasses init dunder init method, and you pass it some keyword arguments. The description, for example, the version, the command manager. This is important. This is actually how. This is what Cliff will use to figure out the actions that you have, because you specify IMDb CLI over here, which matches this over here. So that ties in to the application like that. So and then you have a few other methods which are just you don't have to define these methods. You could just leave them empty if you want. They allow you to do to hook different things into the. You can do different actions. For example, initialize app. Here I've made sure that the IMDb PY logger doesn't give me noise, and etc. So these are like they get run at different points during the IMDb CLI run. Excuse me. So that's that. So with just this, you're able to already run the IMDb CLI command, but none of the actions are defined yet, so it wouldn't really do much. But I can show you already. So here you get a whole bunch of stuff for free. You get version. So this is the version that's defined in that application metadata. You have verbosity. You can make it verbose or quiet. You can have log files, and there's debug as well. And you get some commands here for free. So you get complete. So Cliff supports bash completion. So if you run IMDb CLI complete, it'll spit out the necessary bash stuff to allow a completion. Usually you pipe that into a file and you just source that. And then you have help usage, obviously. And then you already have these three, but these wouldn't really show up at this point. So if we head back over to, oh yeah, here we go. I made the slides, might as well use them. So the commands themselves. Here is the movie create class. This is the class that's going to be used to enact the create movie action. It's a subclass of the command class. This is like a very basic, it doesn't really give you much kind of class. So creating a movie, this docstring is actually used in the description of the command, as you saw before. So create a movie, so that's in the docstring. There's some logger because I'm going to spit out some output later. And then, so the two methods that you want to override are get parser and take action. So the get parser method takes the program name as a argument, and it returns an argument parser. This is actually argparse. So if you know argparse, then this part should be easy. So Cliff is basically a wrapper around argparse. So you call the get parser from the superclass, and you get the parser, and then you add some arguments like title and year, and then you just return the parser. And the second method that you override is take action. So the take action method receives the parsed arguments. It's a namespace object, again, from the argparse library. And you can just do whatever you want. This is where the magic happens. This is where it literally takes action. And so, yeah, so these are basically, this is one whole command. I can demo that right now. So auto completion. You can just create. So it takes, actually, what does it take? So it requires a title and a year. So let's give it a title, Monty-Python, and a year. Yay, we've created a movie called Monty-Python in the year 2021. So that covers the command subclassing. So more interesting now is the lister class. So listers are made specifically for listing things. So the methods that you override are the same. Get parser, in our case, I'm just want to pass it some query, then IMDb CLI movie list is going to query IMDb and return some stuff. That's later, but so we just want to add a query here. We return the parser just like above. Take action, and now instead of returning none, it actually you have to return a tuple, which contains a tuple and an iterable. In this case, it's going to be the column names, and then the iterable is going to be the data that matches these columns. And just above it, here's the actual call to IMDb. So again, we have namespace, but as passed as an argument, as parsed args. From there, I get the query, and I search the movie. And then I just parse over, I iterate over the results. And so you'll notice that there's no formatting here whatsoever. This is just very native data structures. It's just tuples and strings and iterables. The framework takes care of all the formatting for you. So if I take a look at that, so so you get a lot more stuff here. Because it's a lister. So if I just do just a standard query, let's say I want to see the best movie ever made. So now it just found all the different movies that have the Terminator string or something that sounds like Terminator. And so you have different options that you can do. So you can format, instead of being a table format, you could specify CSV, JSON, YAML. You can choose which columns you want to display. You can sort by different columns. And you can choose the sorting order. There's some other options for formatting for CSV, etc. And there's some, so there's a bunch of options to format things. So if I just want to see the title and I want to, so I'll just, title, and I want to have it in YAML. Oops, not YAML, okay, YAML. There you go. So that's it for the lister. Here we go. And then, oops, sorry, there we go. Then there's the show one class of actions. So this one is about showing an individual item from the list. So again, parser, same thing. In this case, I'm adding movie ID. And then the take action in this case, it's a little bit different. It's still a tuple. It's still still the field names are still a tuple as well. And the iterable this time is strings, and because each string in the iterable, it matches a string in the tuple over here, so the field and the field value. So this time I get the movie by its ID, and I do some magic here for the cast because the actors are in a weird data structure that I have to loop over. And then I just return the fields and then the iterable for the different field values over here. So if we take a look at that, so let's just pick a movie here. I guess I'll do a show help first. Right. So same kind of idea. You can choose the formatting, the columns, and same kind of options you got here. So in this case, I'm going to show the first one. Okay, so as you can see, this looks absolutely terrible because the cast field is huge, and it just messes totally with the formatting. That's okay, and there's an option called Fit Width that comes with the framework, and it gives you a much more better looking look, so to speak. So yeah. All right, so that takes care of all the different commands. So there are some caveats that I found with this framework. I find syntax errors are actually hard to debug. When you get a syntax error, the error is, it doesn't give you an error like a syntax error. It gives you garbage. It's weird. So there's some issues that are strange with the framework. And completion, only Bash is supported, but this being an open source project, if you want to add ZSH, you should do a merge request with Cliff, and they will potentially add it if it's good. So yeah, those are the caveats. So I was gonna end it here, but I have just a little bit of time, so I can show you testing with this framework. Because I find that when I write scripts that have a CLI, the CLI part always ends up being really hard to test. With Cliff, it's actually quite nice. You basically just import the different classes you've created, and then you can just pass none and just get the parser, and then you can just do the parse args and assert, and that's it. So you can actually completely test your CLI, which is a really nice thing. Same thing with the take action method. You can also test that if you want. So it's a very simple test. I didn't expect I'd have time to actually show this, but yeah. So that pretty much covers it. If you guys have any questions, go ahead.
Thank you, Martin. Great time management skills. Now I'm going to hand it over to Yannick for the questions.
Hello, Martin.
Hey.
First question, actually, one that I had in mind myself. You added some type annotations to your code, but you didn't talk about type validation with Cliff. So how does that work? Like, do you have something to streamline type validation of the arguments?
Actually, I don't think there is any type validation. Like you said, I put type hints in there because I run just my py myself on the code to be sure that it works. But it's purely on my part. As far as I know, there's no type validation in Cliff.
Excellent. So the type validation would be the arg parse one. So you would need to include the type keyword when you do add argument, and then you would pass a function that will transform that string into the type you want.
Yeah, absolutely, exactly. Yeah, that's true. I totally forgot. You get all the benefits from argparse in Cliff as well. So yeah, totally. Mm-hmm.
Got it. Excellent. And let me see. There is another question. If you tried other alternatives such as Click, can you give some pros and cons? So pros and cons of Cliff versus Click.
So I've never used Click myself, but I expected that question to come up. So I read up really quickly on it, but very quickly. It's definitely a nice framework. I like the decorator method of doing things. The only lack as far as I know, it doesn't take care of any output. That's where I think Cliff is really a winner. Is that it handles output with the tables and all the different formats. I find that Cliff is actually really nice for when you want to write a CLI that's going to go over a REST API, which is basically literally what OpenStack is, right? The client is it's a CLI layer on top of a REST API, and so I find Cliff is really good at that. And Click, I think, doesn't have the output stuff, but I hear good things about Click, so definitely. And I think Click you can just have a one-off script. You don't have to create a package, which is another advantage of Click compared to, let's say, Cliff. Yeah.
Okay, that brings a follow-up question from me. So you need a package. So in your development environment, how does that work? Like, do you install your package? How do you change your code without having to reinstall the package? Like, what's your process there?
So I do pip install -e dot on the inside the package the package directory, and that installs the package in editable mode, and so you can then whatever change you make is immediately available in the IMDb CLI command, so you can test it right away. Is that what you meant, or did you mean more like unit testing? And
no, that covers it. So pip install, and I assume you are inside a virtual environment when you develop.
Yeah. Yes, I use a virtual env wrapper, which is fantastic. I really love using that tool. So I create a virtual environment, and then you just pip install -e in that virtual environment, and then you can just edit and test right away your work.
Excellent. So just a quick reminder, everyone, you can ask your questions on Slack. We're in channel meeting, or on the YouTube comments. Tout le monde, si vous voulez poser vos questions, vous pouvez le faire sur Slack. On est dans le canal meeting. Vous pouvez le faire dans les commentaires de YouTube. Et on a une autre question ici, Martin, en anglais. Is it possible to have dynamic commands? So I assume here that the command that you can have is going to be recognized by your command line based on something else that happened in the environment. So something that you haven't pre-written in the script.
I'm actually not sure. I've never tried to do that. Where could you have dynamic commands? I'm actually not sure. It's something to look into. I haven't seen that in OpenStack, and I haven't seen it in any of the CLI scripts that me or my team have written. So I'll say no for now, but maybe it is possible.
Excellent. Very good. Unfortunately, I think it's all the time we had for questions. Martin, are you going to be part of the 5 à 7 in?
Absolutely.
Excellent. So if you have further questions, everyone, you can ask them as we keep the meeting in Slack, or join us live on Jitsi at the end of the meeting. We're going to have a virtual happy hour, and the link to that is in the description of this video on YouTube. And I'm going to pass it back to Isabelle. Thank you.
Awesome. Thank you, Yannick, and thank you, Martin, for the presentation. See you later in the 5 à 7.
Yep.
Now I'm going to hand it over to Duke, who is a fellow volunteer here at Montréal-Python. He's a beer lover, food lover, and he's going to be talking about the module du mois, which is Pretty Printer. Maintenant, je vais donner la parole à Duke, qui est un bénévole de Montréal-Python, qui est un fan de bière et de bouffe, et il va nous parler du module du mois qui est Pretty Printer. À toi, Duke.
Okay. Merci Isabelle. Est-ce que tout le monde m'entend bien? J'espère que oui. OK, c'est bon. C'est ça, comme Isabelle a présenté, c'est que je vais parler de module du mois qui s'appelle... Est-ce que là, je ne sais pas si tout le monde voit mon écran, là? En tout cas, je pense que oui. C'est ça, le module du mois, je l'appelle toujours Petit Print, parce que je suis habitué avec Print de Python. Mais finalement, à cause que je dois présenter ce truc-là, fait que je suis allé voir la documentation qui est ici. Fait que finalement, c'est plus Data Pretty Printer. Et je vous laisse lire la documentation. Moi, ce que je voulais vous présenter aujourd'hui, c'est peut-être les trois. Il y a plein de d'arguments qu'on peut passer, mais moi, c'est plus le width, le depth et le short depth. Fait que on va commencer avec le depth. Bon, OK, je vous montre tout de suite. Ben, le module, le nom du module nous dit déjà qu'est-ce qu'il fait. C'est juste que là, je vais vous montrer un peu. Voici ce que, admettons, si je fais le pin normal, oups, attends, je vais créer mon truc. Si je fais le pin normal de la chose que je suis allé chercher sur Internet, qui est une page de Python, et on va faire des... Vous voyez que c'est un dictionnaire, mais c'est tout comme mélangeant et très laid, qu'on ne comprend rien. Admettons que si on utilise le pin, le petit printer, encore une fois. Là, voilà, on a comme un dictionnaire qui est un peu plus facile à lire. C'est sûr que là, on a toujours beaucoup de données. C'est difficile d'avoir quelque chose qui est plus beau que ça, on va dire. Et après ça, là, on voit que on a les clés et les ici. Donc, pour une remarque, ici, on voit un liste, ben, il y a 3 points dedans. Ça, c'est parce que dans l'argument depth, je lui donne de 1. Mettons, si on change à 2, et que on roule encore notre script. Encore une fois, là, ici, il passait où mon truc? C'est ici. C'est là, on voit que la liste a aussi été printée ici. La même chose que si on a un autre level qui est mais un autre depth, fait que on va voir ici le dictionnaire qui est printé. Bon, ça c'est pour depth. On va passer au 8 qui est ici. Ben là, je peux aller chercher parce que je veux que mon exemple est un peu plus clair. C'est pour ça que là, je n'utilise plus un dictionnaire qui est comme dégueulasse. Là, on est plus comme les exemples que je suis allé chercher. Ben, j'utilise les exemples de cabane à sucre parce qu'à Montréal, on est dans la saison de cabane à sucre. Fait que vous voyez ici que j'ai un liste qui s'appelle Stuff et un autre liste qui s'appelle, un autre topo qui s'appelle My Topo. On va aller tout de suite. Ma liste a est 40 caractères longs. Fait que si je roule le script 8, voilà. Excuse-moi parce que j'ai comme un peu le truc qui me bloque. Je le vois pas. OK. Fait que là, si c'est 40 caractères, on voit que la liste a été printée correctement. Là, si je mets 39 ici, bon, fait que si c'est une liste, puis si je mets la longueur moins que la liste elle-même, ben, il va automatiquement printer la liste comme élément par élément. Mais ça, parce que j'ai mis 39. Donc, si on met 1, qu'est-ce que ça va donner ici? Ce que vous voyez ici, c'est que dans mon élément qui est oreille de Chris, j'ai j'ai des espaces ici. Donc, il a automatiquement coupé ma liste comme ça, mon élément comme ça. Fait que ça, je n'ai pas encore eu l'occasion d'aller fouiller un peu dans la documentation ou googler beaucoup pour voir pourquoi ça fait ce comportement-là, mais je vous montre l'expérience que j'ai eue avec. Et si on va printer le topo ici, il fait exactement le même comportement, sauf que c'est juste topo. OK, c'est bon. Là, je suis rendu au short dicts. Encore une fois, j'ai mon exemple qui est ici. Là, ben, remarque, c'est qu'il n'est pas en ordre, mais je pense que vous avez déjà deviné qu'il va sortir mon dict, mais je suis juste pour montrer que ça marche et qu'il n'y a pas de bug. OK, on va y aller. Fait que là, j'ai mis le sort dict à faute. Fait que oups, ah, là, c'est quoi ça? Pourquoi j'ai une erreur? Oups. Sortic à faute. C'est quoi l'erreur? Type sortic. C'est bizarre, ça. Pourtant, je l'ai testé. Bon. Attendez-moi un peu. J'espère que j'ai le temps de débloquer un peu. Pourtant, je suis bien dans Python 3. En tout cas, ben, je ne sais pas pourquoi ça ne marche pas, mais bon, je vais vous laisser avec ça. Moi, je vais continuer à débloquer. Fait que, ben, en bref, c'est supposé de sortir le dictionnaire. C'est ça, par qui, comme par exemple. Mais la variable sort dict est par défaut à true. Donc, si on met rien, ah oui, c'est vrai, je pourrais peut-être faire ça. Ah, voilà, c'est ça. Ça sortait mon dictionnaire. Mais c'est bon, c'est tout pour moi. Merci pour votre attention.
Merci Duc pour ta présentation et pour le thème de cabane à sucre. On te fera tout à l'heure au 5 à 7. Thank you Duc for this presentation. See you later in the happy hour.
C'est bon.
Ok, maintenant on va passer à la dernière partie de cet événement. Ça va être une présentation de Christian Hudon. Quelques petits mots sur lui. Donc il fait de la programmation depuis qu'il est enfant. Il a commencé sur un TRS-80 PC3 micro-ordinateur. J'ai dû googler ce que c'était parce que je crois que c'était avant ma naissance. Ensuite, il est passé sur un Commodore 64 et maintenant il est un adepte de machine learning. Et il va nous parler de profilage. Okay, now we're gonna pass to the last presentation of the event. It's gonna be about profiling with Christian Hudon. Just a little quick words about him. He's passionate about programming since he was a kid, and he started on a TRS-80PC3 pocket computer and then Commodore 64. And I was just saying that I had to Google this because I didn't know what it was, and it's from before I was even born. Now he's into machine learning, and he's going to be talking about profiling. Here you go, Christian.
Thank you for the introduction, Isabelle. So, why this talk? Let's start with an example. This couldn't have been a better timing for this talk. So this is an article on Ars Technica. GT Online is a computer game that sold very well. It's been around for a little while, like many years. And it was taking a long time to start up, to load when you started the game. And this is puzzling because this was even like an old game, not a very recent one. It was Annoying enough that at some point, one of the players like pulled out like all the tools like disassembler, profiler, and profiled the binary code of GTA Online to figure out why it was taking so long to load. And that person found like two simple things. This was like I assume like game engine codes or C++. So the loading routine was loading a huge JSON file with the contents of all the items in the in-game store. It was calling the string length function repeatedly on some segments of that file, but that function was even returning the same number. So there were like unnecessary calls to that function. And the other part, some of the results were stored and looked up in a list instead of a dictionary. So just by changing in the binary code these two things, like caching the call to string length and like using a dictionary instead of a list, that person was able to take off like 70% of the load type for GTA Online. And so let's do a little math on that. So like about still 120,000 players every day for GTA 5 Online, still a popular game. The game has been out for 7.5 years roughly. And then the average from a survey on Reddit of players was like around 5 minutes of loading time. So if you multiply all this together, you end up with 1,140,625 total days waiting for the game to load. And also, this was a lot of work for that person to like figure out and fix because they didn't have access to the source code at all. But like, what about the people developing the game? So the two fixes were like very straightforward. And so maybe like running a profiler on the code, figuring out that these two hotspots were there, and then like doing the fixes like was about a day of work. So like the return on investment there is like over 1 in a million days saved for 1 day of work, 1 day of additional work, and for the person implementing that feature. So granted, that's an extreme example, but in a sense, I get it. Like if you're not familiar with a tool, you're kind of not going to reach for it unless you have to. So this was, however, in C++. Are things potentially different in Python? Not really, sadly. So for the last 4 years, JetBrains and the Python Software Foundation have been putting out the surveys of Python developers. It asks a lot of questions. You can learn really interesting things from it. And one of the questions is about tools. At the top, you see like usual suspects, like use version control, refactor your code. And then all the way to the bottom, near the bottom, you see use a Python profiler with 42% saying at least sometimes, and then 58% saying never or almost never. So the goal of this talk is to break the ice and give you a starter kit of sorts for using profilers, so that when you're in a similar situation, and this is a relevant tool, you'll reach out for it, without hesitation. So in the talk, I'll discuss how to think about profiling, show you the basics of 4 profilers, and list some ideas to consider once you found a slow spot in your code. So if you've never used a profiler, hopefully after this talk, the ice will be broken. You'll reach for a profiler as you think, this feels kind of slow when you run your code. And if you're in a whole hands at this, the comparison of the 4 profilers should be useful. And also I'll have like links to further readings on the last slide. And by the way, also that last slide will contain a link to the slides, example code on the GitHub also. So that's a good slide to take a screenshot of. So first thing, how to think about profiling. So I've been reading in the last over the last 6 months a fair amount of blog articles, like various things about Python and also GPU profiling. There's some really good and impressive examples of profiling out there, so I learned a lot from them. However, one thing that was kind of bugging me reading them is that they don't mention key steps, I feel, at the beginning. And when you read what the person is doing, it's really clear that that person is thinking about these steps, but they don't mention them. So it may not be clear to everyone that this is happening behind the scene. So first, let's talk about the how a little bit. So one of the key first steps for me that's often done implicitly and doesn't need to take a lot of time, especially if you're used to it, is to build the model of the system, at least in your head. So modern computers are very complex systems. So if you were to optimize in the details, the model could be very complicated. But I mean, you don't need all that complexity if you're starting on your initial runs with a profiler, and if the aim is just to get find some low-hanging fruits and speed them up. Like any basic model will do, as long as there's 3-4 boxes there. That model will be useful, and the model should contain pieces that interact in your system. So if you're waiting in a database, that should probably be a box in your model. If you're doing a lot of transfers to RAM or to disk, that should be a box in your model, I mean. And what this allows you to do when you see profiling results is to reason about interaction between the different pieces of your system and also the bottlenecks, because especially bottlenecks are super important to pay attention to. So if you're to take an obvious example, if your code is waiting on a database for some results, it doesn't matter how much you speed up the code after that, it'll still be as slow as the database. Another key question where to focus your effort is where to focus your efforts. There's a key piece of vintage computer science, actually from 1967, that's relevant here. It's called Amdahl's Law. So let's talk about that a little bit. If you go to the Wikipedia article, you'll see formula and everything, but it's the ideas that are important. So let's go over those. Basically, the question was okay, you have a program that runs for, let's say, 100 seconds, 100% of the running time, and there's a piece in the program that you can speed up. At the time, it was by parallelizing it, but any kind of speed up would be relevant here. And so what's the maximum speed up that you can gain from parallelizing that piece of code, given if you parallelize it by 1, 2, 10 times. So this allows you to compute that, but just looking at things, you'll see you can use this even if you're not speeding things up by parallelizing, to run just experiments in your head. So if you're speeding up, if you're a piece of code that's 20% of the running time of your program, and you speed it up by 2 times, so instead of 100 seconds, you'll have 90 seconds, because the 20 seconds will have gone to 10. And as an example, so you see twice 2x speed up on a section of code that's a small section of code doesn't end up having a huge impact. And even you can take that to the limit. What if you have that, take that section of code and you make it infinitely fast, so it takes 0 seconds to run, you'd still go down only from 100 seconds to 80 seconds. So focusing on chunks that have chunks of code that have a big chunk of the running time of your program is key to have an impact when you're optimizing. And so putting all of these things together, here's a blueprint on how to think about the whole process. Most of these steps don't need to take long. It'll pay to be methodical and systematic, however. So the first step is to set yourself up for repeatable measurements. So you'll be doing at least profiling run before and after your change, maybe multiple ones. So it's important to make sure that the numbers that you get are comparable. So if you have a system that's very busy, then maybe shut down some programs, or if you're doing machine learning or something like that, or using something in the cloud, then you're sending your code to run on a remote machine. Often these systems will have a pool of machines with different CPUs, different GPUs, different generations. So you would pay off there to make sure to always get the same CPU and GPU kind, so you can compare your measurements. Also, if you're going to be iterating, shorter profiling runtime is better. So it's worth it also to especially if you have a for loop that's iterating on something, you figure out a smaller subset of the data and then feed that to the model, because the faster you can iterate, the more things you can try out. Step 3, build the model. We covered that. Step 4, don't guess, measure. This is a tool of profiling, so use profilers. And then once you have measures and you have some hotspots, you can change the code. One change will be easier to manage, and then you measure the impact by running the profiler again and repeat until satisfied or out of time. If you you're doing this kind of not as a separate task, but as something, oh, like this is slow, let me try if I can speed it up quickly. Time boxing is a good strategy for like working on this. Let's talk about the tools now. So first, there are multiple kinds of profilers, and they'll have different strengths. So it's important to understand the differences because they'll allow you to pick the right tool for the right problem. The first category here is what I would call classical profilers. So think of C profile in Python, for example. And let's say your language doesn't have a profiler. That's probably the first thing, like a classical profiler is probably the first thing that will pop up. I mean, you don't have a profiler, you want a profile. So like you instrument the beginning and end of each function by logging the time taken, the number of calls, and all these things, and you'll get a trace, and you can figure out where things are slow from that. So one issue from like this is that there are two ways your program can be slow. Like you can have one function that runs for a long time, or you can have one function that runs for a very short time, but is called very often. And so for the second case, if you're adding overhead on every function call, like with measurements with a classical profiler, will tend to distort a lot what you get in terms of output. So to solve that, like the second kind of profiler was invented, let's say, so sampling profilers. The way sampling profilers work is that instead of instrumenting your program and running at the beginning and end of every function call, they'll interrupt your program every so often and take a snapshot of where the program is at. Like say 1,000 times per second, they just record, oh, I'm in this function. This is the call stack that led to being here. And they accumulate those. Excuse me. The nice thing about this is that the overhead is constant. And so like for both cases, one function that takes a really long time or a small function that doesn't take a lot of time but is called a lot, you'll get the same, with the same overhead, you'll still catch that function and the measurements won't be distorted as much. But then sampling profiler give you a view of what's happening on average in your program in a sense. They'll be very good at that, but maybe your problem is not with average, but extreme. So let's say you're writing some kind of server that answers requests, and every 100th request or every 1,000 requests, it takes like 10 times the time. And you want to be able to find that request, understand the problem, and then make it faster to have better performance overall. So like a sampling profiler will kind of average everything together and will measure averages. So it'll be very easy to miss those kinds of events. So tracing profilers are kind of the return of classical profilers in a sense. But the perspective is different. So instead of starting with like instrumenting thing, they'll often start with the budget. So especially if you want to run these in production, like the budgets will be very tight. So let's say I don't want to disturb my running program too much. So maybe I'll have like 5% of the CPU time, or like even 1% for something that's always running in production of the CPU time to dedicate to like recording my traces. And then you'll engineer your profiler to work as much as possible with that. And yeah, these profilers are good for measuring extreme events, basically. That's the landscape. And now that we have an idea of the general landscape, let's dig into specific tools. So the first profiler that I've tried out is PyInstrument. I've been using it a fair amount in the last 6 months. So PyInstrument is a sampling profiler, so it'll be good at describing averages. It's easy to run. One distinction from PyInstrument compared to some other ones is that it measures wall clock time and also measures full stack traces. Wall clock, yeah. For people that are new to programming, wall clock time is a bit of a funny name. So like, I guess back in the days, people had like, I have a clock on my wall right now, actually, but yeah, it's not all that common. But wall clock time is saying how much does it take to actually run instead of like how much CPU time your program is occupying. So there are advantages and disadvantages to that. The advantage is that if you have a function that's taking a lot of time because it's waiting on an external system, and then it's not running like waiting in the database waiting on the connection request, it'll still show up in the profile. But the disadvantage is that the measurements will be more sensitive to other things running in your machine. So if your CPU is busy with a ton of other stuff, that will distort this measurement more than like time that the process has spent running. Another interesting thing about PyInstrument is that it has hooks to profile Django or Flask requests. So like if that's something you're doing that would be a worthwhile program to run, you can install the program via pip, and then running the basics of it is really easy, as you can see. And the output, it can output to the screen, but it can also output an HTML report. Let me show you. The report looks like that. And you can see it records the full stack traces. The number is the duration. So red is higher than green. You can collapse entries. And so you can generally get a feel of where your program is spending its time. And it'll even work across like C code boundaries. So like if you have some Python code that's calling some C code, and inside that C code you see it's calling a Python function, which is probably not a good idea, especially if it's calling it often. You'll see that reflected in the profile. Oh, and I was supposed not to do that. Let me just give me a couple seconds to get my setup back. Nope, not this. Here. Thank you. Sorry about that. Second profiler is PySpy. PySpy is also a sampling profiler. The difference with PySpy is that it runs totally outside the process, and so it can profile already running Python programs even in production. So it attaches to the process, the already running process, and it reads the memory to figure out where your program is. So, for example, it's got a mode similar to top, where you can do PySpy top a program, and it'll show you things that are actually happening in the program right now. There's also a dump command that you can run to like dump profile for an existing running program. But the disadvantages of that is that PySpy may require special permissions or configurations. So like on my Mac currently, for example, you need to run it with sudo. Or if you're running something inside containers, you'll have some kind of configuration to do to let another process read the memory of the Python program you're running. And so running PySpy is fairly similar to running PyInstrument, like the basics are simple. And the output is an SGV file that you can load inside Chrome as a flame graph. And you see horizontally is the length of time the program has been running. And then vertically, you can see different stack traces, and you can focus on some of the stack traces. So this is the function that allocates a lot in the profile. So that's what PySpy looks like in terms of reports. Another profiler, third one, is Scalene. So Scalene is also a sampling profiler. What's interesting about Scalene is that it profiles both CPU and memory usage, and even profiles GPU usage too. I haven't tried it. I've used some other tools. I don't know how well it works or not. It wouldn't not necessarily be the tool I would tend to reach for GPU, but I haven't tried it, so I don't know. What Scalene? Yeah, Scalene can profile both CPU and memory usage. So if you have your program is taking a lot of memory, you'll see where allocations happen. And the other interesting thing about it is that it profiles at the line level. So you'll see which line is slow, which line is allocating memory. Similar to PyInstrument, it can produce an HTML report. And the report looks like this, actually. So you see various column times in Python, system time, the memory. So my function that allocates a gigabyte of memory shows up here. You see a kind of a spark line with memory usage here over the program's lifetime. And so that makes it easy to see what's happening with your program in terms of both memory usage, memory transfer, CPU, and even potentially GPU usage. And then a fourth program is VisTracer. So VisTracer is a tracing profiler. So when you want to focus on rare events, not averages. I've read about it only recently, so I haven't had an occasion to use it a lot, but it's been used like very successfully by both Dask and VAX folks, which are like VAX is an out-of-core pandas like tool that's multi-core, and Dask is a tool to schedule different Python computations. So both complex tools, and they've used this to good impact to like figure out bottlenecks and like slowdowns in their system. So the downside of this tool is that's a more complex tool, so you'll probably need to read the manual a little bit to use it. But I mean, if it's a good tool to have in the toolbox as a second profiler, or if you have more difficult problems. And like the other ones, it produces an HTML report, although here report is not quite the right word because it's more like a full application. As far as I could tell, it needs Chrome to run. But you see, and I haven't tried it a whole lot. I would need to read the manual, but you see the runtime of your program, except you can, there's a variety of options that you can view here, various menus on the side. So, and if you click, yeah, you'll see details about what's happening. So that's a like potential good second tool to have in the toolbox if you have more difficult profiling problems to solve. So once you know how to where to focus, let's talk a little bit about what to try. And this could be a whole talk in itself, but at least here's some ideas quickly to get you started. If you have a profile a hotspot and you want to think of what you could apply to make it faster. So one thing that's really important with profiling and that profilers are helpful at in general is like looking at the big picture. So like when you're coding, you'll tend to be in your code. Maybe it's a big code base that you don't know very well, and you're making a change where you need it to be. And it's hard to have a view of the big picture. But maybe your code is calling something repeatedly that's not necessary or something like that. So a profiler will be very good at popping that up. And so having a global view, it'll be easy to like see if there are bottlenecks, if there's repeated work, is there places we can do less work. Yeah, so that's the first thing to try to pay attention to. Another thing to pay attention to is focus on overhead. So if you're getting results from a database, and each time you ask the database for a row, it has a fixed overhead, then can you batch things to reduce that overhead? Another interesting thing to consider is it'll help to understand the libraries that you're using. So a common example, like basic example of slowdowns in Python is like appending strings repeatedly in a for loop. And that's because strings are immutables. Like each temporary string, it'll be slow because you're creating a ton of temporary strings on your way to your final string. So having some kind of understanding of how your libraries are going under the hood will help you get a feel for what's slow and what's fast, what to avoid. If you can, like especially for scientific code, but even not, like vectorize or delegate the work to fast third-party code. So if someone has done some code that like, and I've pulled a lot of effort into to make it fast, like just use that code. Another option is to parallelize. Python is sometimes not the best language for parallelizing, but it's doable. Using more efficient data structures, like if you're doing lookups, like use a dict, so it's obvious, should be pretty obvious when you say it like that, but like be aware of the access patterns of your data structures and figure out if there's a data structure that's better suited to them. Another set of tools to have in the toolbox when this is not enough is Cython and Numba also. So let's end with a couple wild ideas. So the first one is profile all functionality at least once. So I mean, if profiling is a big thing and you need to learn the tools, it'll be hard to do. But if this is something that's easy to pull out of the toolbox, like maybe there'll be no obvious hotspots, but maybe they will, or maybe there'll be a glaring bottleneck in your code, and just like 1 hour more, you can make something like 50% faster, or like 2 times or even 10 times faster. So you'll never know until you look. So one of my wish lists would be like every pull request, every piece of code that you've run, like profile it at least once. And let's even be crazier, like profile in your CI. So like maybe think of your program and think of like a couple of things that should be fast. And just like you have like unit tests that make sure that if your program is working, it keeps working. Then if you have profiling in your CI, if something is fast, you'll notice as soon as there's a change that introduces a slowdown, and then you can fix it. So maybe add some time measurements or profiling run in your CI running on every commit, and then when you see regression, you can fix it right away. So that's it for today. Thank you. This is the good slide to snapshot. It's got further readings. The first one is really interesting. So this was the Profiler Starter Kit. So this is the other end of the spectrum, showing you how much work there is in profiling in the details. So and the person doing it needs a model of all the different pieces in the modern CPU, all the different variants. So that's like optimization in depth. And otherwise, at the bottom, you'll see a link to my blog, my website with the slides, and a link to the GitHub. Thank you very much. And if there are questions, I'll be happy to answer them.
Thank you, Tristan. That was such an interesting talk. And thanks for sharing all of those resources. We have time for a quick 5 minutes of questions. So I'm going to hand it over to Yannick. On va avoir 5 minutes de questions. Je vais passer la parole à Yannick.
Allô, Christian. J'invite tout le monde à poser leurs questions sur Slack ou sur YouTube. Aucun problème de ce côté-là. Everyone, please ask your questions either on Slack or as a YouTube comment. And I will start with the first one. So, Christian, Donald Knuth famously said that premature optimization is the root of all evil. And your talk is mostly about optimization. So how do you balance that idea that if you optimize too much, your code is going to become perhaps complicated, hard to maintain?
Yeah, no, that's a really good point. I wanted to talk about this, but didn't go into the details because if you, the modern equivalent of this, if you go like on Stack Overflow, sometimes you see someone asking a question and then you see one of the answers and the person is like, it's a one-line answer, right? How do I do this thing in Python? And then you see the person going to the trouble of like, oh, like you can do it this way and this way and this way, and this one is like a little bit faster. So that's totally premature optimization. It doesn't matter. Like the slowdowns in your program will come from a couple key places. And so in the beginning, when you write your code, you should focus on let's avoid major gotchas. Let's if some things are slow by nature because immutable versus mutable, you want to go in the right direction, but otherwise just write things to be readable. And then once you're done with the feature, that's when it's a good time to start pulling out the profiler and see if there are like obvious hotspots, slowdowns, bottlenecks.
Excellent. Let me see. I don't see any questions yet. So people, don't be shy. You can ask your questions on Slack or on YouTube. Second question from me, Christian. So you mentioned parallelization. Async is a good way to do that in Python. But that goes against one of your comment to make your environment repeatable. So let's say you go async or you have some level of parallelism. How do you end up in a repeatable environment where your profiling runs are useful?
Yeah. Async is a good question. My code has been CPU bound for a long time, so I would need to think about the async like IO bound use case. But like at least I can answer for like CPU bound code. So machine learning or any kind of code, there'll be parallelization happening, and sometimes at various levels. So like that's where building a model becomes interesting too. So like if you have a model of how your code is going to run, I'll take machine learning just as an example. You're training this model and you're trying various different hyperparameter settings, and you're picking the right one. So that's something that like trivially scalable. You're trying like multiple things in parallel. So you can profile on just one, and then you can extrapolate the result. So like another step in that is your training loop will like run over your whole data set and do like a forward pass, and then we'll do a backward pass and figure out how to move the parameters so your model improves. And so the same, like if you have a data set of 1 million lines and you have a data set of 1,000 lines, I mean, the model won't be as good for a data set of 1,000 lines, but the same things will be happening, the same bottlenecks will be there. And once you've sped up your training for the 1,000 line code, 1,000 line data set, you'll find the same gains for like a bigger data set.
Excellent. So basically you look at the smaller run of the profiler, you do a little bit of back of the envelope math to see what's going to be the impact of scaling it to the production level.
Yeah, and especially like if you have something like this, like with a setup phase that's relatively quick, a really long computation phase or like main phase, like when you train things, obviously the setup phase will be a lot longer, but it's not where you should spend your efforts because this thing that's short will be stretched by like 1,000 times.
Excellent. Very good. Let me see. I have a question here. So if I'd like to do load tests to profile functionalities such as writing to a database or calling APIs, are there a useful tool for these kind of use cases? So I think the essence of the question here is how do I simulate a high load in my development environment?
Yes, the general answer is yes. Yeah, and I don't know. Yeah, I don't know about database tools. I know like that for sending like web servers sending requests, there's like various tools for that, but I don't know the names offhand. But you can bet there'll be like tools for like all these cases. These are common use cases. I mean, I assume if you search for like web server like load testing, there'll be tools. But I don't know. Yeah, and I've seen the names, but they don't come to.
At least for web applications, I think I will point out to we had the talk by Tarek Ziadeh in the Montreal-Python, I think 4 months ago. So that would be a good place to start. I think it was Molotov that he was talking about, a tool developed at Mozilla. That seemed pretty easy to deploy as long as you have web-facing endpoints, so for REST APIs or for a web application. Excellent, very good. That might be all the time we had for questions. So Christian, thank you again very much. I hope you will be able to join us at the virtual happy hour on Jitsi so that people can ask you other questions.
Sure, yeah.
Excellent.
Thank you.
Perfect. I will pass it again to Isabelle.
Thank you, Christian. Thank you, Martin, Duc, and all the Montreal-Python volunteers who made this event happen. We are wrapping up. I just wanted to mention that we are looking for volunteers in the Montreal-Python team as well as some speakers for following events. I forgot to share my screen. And so if you'd like to join, please reach out on Slack. On arrive à la fin de l'événement. Merci à tout le monde, Martin, Christian, Duc et les bénévoles de Montréal-Python qui ont participé à cet événement. Juste un petit rappel qu'on cherche des bénévoles pour Montréal-Python et des speakers. Si vous avez quelque chose à partager, sentez-vous à l'aise de nous parler sur Slack.